Is it possible for us to conquer the inevitable process of aging and death? This question has been at the forefront of scientific investigation for decades, perhaps even centuries. However, the answer might be closer than we think. For millennia, humans have watched as their loved ones passed, as aging slowly but surely took away their vitality. This inevitability led to a feeling of learned helplessness, and countless justifications were created to soften the blow. Some argue that without death, we cannot truly appreciate life. Even scientists, after countless unsuccessful attempts at battling aging, shifted their focus from radically extending life to merely improving its quality, targeting specific age-related diseases. But now the necessary technical prerequisites have matured and a sufficient amount of data has been accumulated to seriously tackle aging. 10 years of personal research and modern scientific achievements have led us to understand how we might achieve this. All organisms age, but each new organism begins life at 0 age. This means that rejuvenation is inherent in each of us, but it only materializes at a certain stage of development. There have been numerous hypotheses in science about when rejuvenation ends and aging begins. In sex cells, at birth, between 10 to 14 years when mortality is minimal, up to 20 to 25 years when the body is fully formed and most functional, or when age-related diseases appear. Recently, Vadim Gladishev's team demonstrated that rejuvenation ends and aging begins even in the early embryonic period. This made sense to us because only early embryonic, totipotent and pluripotent cells show 0 age by all indicators: transcriptome, proteome, and most importantly, epigenetic clocks. They are capable of infinite division under certain conditions, meaning they can remove all arising malfunctions. As soon as they embark on the path of specialization, they lose these abilities. They become mortal, aging. Scientists have learned how to revert the oldest centenarian cell back to 0 age, to an induced pluripotent state, IPS, using Yamanaka's embryonic factors. The challenge now is learning how to replace the old cells of an organism with these young ones and age-related diseases, and aging will become a thing of the past. However, the insurmountable obstacle so far has been the risk of tumor formation when using IPS or their specialized descendants, because it is impossible to fully cleanse the differentiated cells obtained from IPS residues. Yet at the end of 2023, our team managed to obtain very young cells from an aged organism without Yamanaka factors and without the risk of tumors. In conclusion, the possibility of defeating aging and death is no longer a distant dream, but a tangible reality within our grasp. The journey has been long, filled with trial and error, but we stand on the precipice of a breakthrough. As we continue to push the boundaries of what we know about aging and death, we are slowly but surely inching closer to that elusive goal of immortality. Perhaps with your support, victory may be closer than you think. After all, there's no time to waste.